Hello Python for Data Science community, and welcome back. Today we're going to get classy. That's why if you could see me right now, you'd see that I'm wearing this super awesome, super flashy tuxedo. I'm looking pretty good. Anyway, I'm not saying you're not classy already, but I'm going to help you make your code classy too. I know for the first several years of my data science career, most of my code took the form of standalone scripts. Now there's nothing inherently wrong with that. That approach works for lots of scenarios. But when applied at scale, that approach can produce a lot of redundant code that's hard to maintain and troubleshoot. So, as the projects I work on have grown in complexity and scale, and as I found myself working on DevOps components like automation and building data pipelines, I've learned the value of thinking like a programmer when writing code. So, to that end, I've started using things like custom Python classes quite a bit. And one of the areas I find them very helpful is in the data munging phase. Using classes for data munging has a few benefits. It abstracts out the data munging code so it's easier to maintain. It keeps the project metadata with the actual data. It helps separate code by purpose, making your code easier to read. And it makes it easier to package the code for sharing. That second point, though, the fact that it allows you to keep the metadata with the actual data, is one of my favorite benefits of using classes, custom classes for data management. So what that means is if you think about a normal project, you've got a lot of information that goes along with it. So there's not just the data. There may be runtime, there may be the name of the project, there may be the location that some samples were pulled from, there may be some sort of data generation information that you want to keep connected with the data. So there's all types of metadata that go along with that data that you're actually going to be analyzing. And when you write up your model performances, for example, I often store them in a database. When you write up your model performance information, you often want to keep that metadata. So having a custom class that keeps all that together as you import it and do any necessary transformations, and then export it, is very useful. So today I'm going to give you a simple dip your toe in the water introduction to creating a custom class, and for this specific purpose of data munging. You can do custom data classes for lots of different things, and I do use them for lots of different things. But one of the areas that's a great way to just get started with it is for your data munging and the early parts of your data pipeline. Specifically, we're going to create a class that imports some data, then recodes it, and then exports it to a database. So you can see that this class is going to have essentially three methods that go along with it. Obviously, production use cases are going to be more complex generally, but this is a good place to start. So let's go. First of all, I'm going to do some housekeeping. I'm going to import some libraries, add a doc string. Okay, so this is just basic imports for a couple of things that we're going to need as we go through this example. Nothing too groundbreaking here. Now your basic class structure is going to look like this. First, we define the class. Instead of using a define like we'd use for a function, we're going to use a class as the keyword to initiate the definition. Now I'm going to use the snail data because what's classier than snails? As I mentioned a minute ago, our class is going to have three basic methods: import, recode, and export. So the basic structure is going to look like this. Obviously, there's going to be more that goes under each of these methods, but this is really what it all boils down to. We're creating a class that's called snail data, that's going to work with our snail data, and it's going to do these three main tasks: import, recode, export. Now there's something slightly unique about creating a class that you don't have to worry about with a function. Every class has what's called a dunder init method. This is something that runs when the class is instantiated, when the class is first created as a new object. This is how it looks. The purpose of this init method is to set up any variables, any objects, or any attributes that you may need from the very beginning of when you start using this class. It also allows you to define parameters that are going to be used when the class is instantiated, sort of like you would do with a function. We're going to be using three parameters when we call or instantiate our class for the first time. We're going to have a data source, a project name, and sample location. I'm going to add those now. Okay, so if you've written functions before, this should feel familiar. This is very similar to how you would define parameters in a function. Okay, now you'll notice that we have these three new parameters, and in addition to that, we have this reference to self, and that just refers to the object itself. So what we'll be able to do using this self reference is pull up any of the attributes that are part of this object. I'll show you how to do that in a second. But first, I need to show you how to set things as attributes in this object. So after we have passed these data source, project name, and sample location parameters, we want to assign them to attributes for this object. We'll do it like this. Okay, so just like if you were assigning a new column to a data frame, you can use the same sort of syntax. Now it's obviously doing something different on the back end, but you can use the same sort of syntax to create an attribute for our class that we're initiating as it's initiating. So what we're saying here is take the information that's passed in the data source parameter when we instantiate this class, and assign it to the data source attribute of this class. Now we could have called this something different, so I could have called this something like data location, and it would have worked the same way. The attribute for the class would just have been called data location, but I like to keep them the same for simplicity and for clarity. It helps me when I'm tracing things out. So in addition to creating attributes in the class for each of these parameters that are passed, I also created an empty attribute called df. So as you can see, you can also create empty objects or new attributes that aren't the results of parameters being passed in this init method. Okay, so now when I instantiate this snail data class, it's going to, first I have to pass information for these three parameters, and then it will take that information and it will assign it to attributes within this class, and we'll have it ready to go. I'll show you how to do that in just a minute, but first let's go ahead and fill out the things that we're going to need for these other methods, the import, recode, and export methods. I'm going to just fill those in real quickly, and then I'll come back and step through what they're doing as an overview. Okay, so we're all set up and ready to go here. What I've done is I've added some additional functionality to the structure, the skeleton structure that we had here. Each of these methods at minimum requires a reference to self so that you can pull from those attributes that we had defined, that have been defined in various places within that object. So what I've done in the import statement is, first I've given some column names that we're going to use later on. These are the column names for the snail data. And then I'm saying read underscore CSV from the data source that we're going to pass. We're going to pass a URL that will go out and fetch the snail data. And then I'm just giving the column names. So this is pretty much just a straightforward pandas read underscore CSV that is going to create a data frame and assign that data frame to the df attribute of the class that we instantiate. Then when we run the recode data, this is a method that you could use to do just any standard transformations that you always do on this data that come in. We're going to just create a square of the whole weight of the snail. Then we're going to create a variable that is the log of the length of the snail. These are just random things that occurred to me as I was writing this code, so I don't know that they have any impact on anything, but just examples of transformations that you could do. And we're also going to append some of the metadata information. So we're going to add the project name to the data frame, and the sample location to the data frame. So now we'll have that information connected with the data, and there are tons of different ways you could do this. Obviously, there are more efficient ways of tracking this project name and sample location than actually adding it to every row in the data, but this is one way to do it, and it's good for example purposes. So once we run this recode data, I'll be able to show you that we have these new variables created and appended. And then after we've recoded the data, maybe we've done something else with it, but now we're ready to export that data to be archived somewhere. And so as part of the export data method, what I'm doing is connecting to a SQLite database that I've set up just for an example purpose, and I'm writing this data out to that SQLite database, and then we're going to pull it back just to verify that it's there. But so here you can see again the basic sort of data pipeline structure that you might use for anything, and we've got it encapsulated in a class that we can use for any new batch of data that comes in. Okay, so let's see it in action. As you can see here, I've got the URL for the snail data that we're going to be pulling from. So now the first thing that we have to do is create an instance of this class. Doing this just runs that init method that we have above. It doesn't do anything else. Okay, so this is how we start an instance of our snail data class. This project happens to be a super secret NASA project where we are analyzing snail data collected from Mars or something like that. I'm not sure where that came from, but let's roll with it. Okay, so the syntax that you see here is going to create an instance of the snail data class called snail underscore data, and it's going to assign it the project name AstroSnail project underscore or1, and it's going to assign it the sample location of Mars because this is a top secret snail data collection for Mars. Now you know. You can usually tell how late it was when I was doing the example code for one of these videos by how crazy it gets, and this is probably after 11:30 here, which is kind of late for me. Anyway, we've got our Martian snail collection. Let's go ahead with it. So first, we do all the definitions above, and now, when we run this, we'll have an object, a snail underscore data object, not snail, snail. And that, because of our init method, that snail data object will have things like sample location defined and project name defined. There you go. And it should also have nothing in the snail df attribute. Okay, so we're good. Now, the first thing that we're going to do is run our import method for this class. We've already defined the URL in the instance because that's what we provided it when we created the instance. So now all we have to do is run the import method, and it will run everything that you see here. So let's do that. Take it just a second to go fetch the data, and now that it's done, we should be able to actually see data in our df attribute. And there you go. So now we have data that we can work with. Next step is to simply run the recodes function that we have created. Again, we don't have to pass it any information because we've got everything defined in the recode underscore data method. Now, we should be able to see that instead of 9 columns, we have 13 columns. We do in fact see that, and you can also see that you can visually verify that the project information was appended in columns of the room. Okay, so we're making great progress. The next thing that we want to do after we've, probably done some sort of analysis of this data is actually export it so that we can archive it. So I bet you can guess how that's going to work. When we run this, it will connect to a SQLite database, export the data frame to that database, and close that database, and then we'll be able to just run a quick SQL command to confirm that everything is there. Yes. So having already run through this example to make sure that it was going to work, I broke it. So give me a second just to fix that. Okay, so what happened is I had already run this to make sure that everything was going to work, and when I did so, it created the snails table, and so it's giving me an error that I already had the snails table created. So I just went in, blew that table away, and now we're back. So once more, we'll run this export data. See that it worked fine this time, and we can verify that there's actually data there by creating a little SQL. And when I run this, I should get a data frame back that looks just like the one that we would have exported. And there we go. You'll notice that we have 14 columns because it exported the index as an additional column. So we have one more column than we actually had in the data frame that we were looking at a few minutes ago because of the addition of that index. So this has just been a quick intro to using custom classes in your data science work. Obviously, you can get a lot more complex and fancy with this approach, so feel free to see what you can do. To help you with that, I will put some reference information and some resources in this final code when it's posted on GitHub, and I'll also put some in the description for this video. As always, please take a quick second to subscribe. It helps keep me motivated to produce more content. Give this video a thumbs up if you like it. Feel free to comment, ask any additional questions in the comments. So that's all I have for now. Thanks for watching, and stay classy, PyTS.